we're going to start meeting at 5 o'clock in the morning so we can get over some stuff. No, I'm joking.
Yeah,
I can't get me anymore. Okay, so you need to get out your notes because you are right now in my geometry class, okay? So you need to get out notes, and for you guys, remember in the back of your, there's a good place for notes, right? In the back of your packet. Didn't I give you some note pages back there? Okay. So you have that if you don't want to use your own, paper or whatever. Okay, so let's start out, and while you're kind of warming up, getting in class, bell ringer here, I want you to find the hypotenuse in the following. So if you'll draw this right triangle, and this side leg is 5, this leg is 3, and there's the hypotenuse. Why don't you go ahead and find the hypotenuse in that diagram for me. Go ahead. Here, you're going to have to get your notebook out a little quicker. When the bell rings, you should be ready to go.
Yes, sir.
Thank you. John, Brittany, secretary, right?
He's trying to copy me.
Well, it's okay. It's a bell ring. You guys can work together if you need. Gary doesn't even have a pencil. Gary's sending an email to your mother as soon as
Here, Gary.
we are done with class. Maybe when you think you know an answer, maybe share it with somebody near you, see if you got the same thing. Maddie and Colin are done, so maybe we could look and see if you got the same things. Maddie, are you texting underneath there?
Yeah,
You
it's
need
important.
to get that text out, and then I know you're texting because nobody just looks down at the crotch and laughs.
No, it's my boss.
Right? I mean, no sane person. As always, we're waiting for Gary. Okay, so that's enough time for the bell ringer. What'd you get for an answer? Who can tell me what they got for an answer? Who wants to share? What'd you get, John?
Square root of 34.
Square root of 34. Okay, so I'm assuming everybody can do that. That's easy. What did you use? What theorem or formula did you use to find that answer? Yes, John, since you gave us the answer. Pythagorean theorem. So when you set up the Pythagorean theorem, what did it look like on your paper?
A squared plus B squared equals H squared.
A squared plus B squared equals H squared. Okay, so then what was A? 3, so you said 3 squared. What was B?
5.
So that's 5 squared equals H squared. And I'll assume everybody can do the work from here. H squared, 34. So does everybody see how John got square root of 34? It looked like everybody got that there. So here's my big question for right now, though, is I want you to think about this. How much information do you need about a triangle in order to use the Pythagorean theorem? Let's think about that question again as I say it again. How much information about the triangle do you need in order to use the Pythagorean theorem? Just think about that for a second. How much information do you need about a triangle in order to use the Pythagorean theorem? Now, before you answer, go ahead and share with the partner there, and then I'll have you. What do you need to know? How much information? Colin, what do you need to know if you're going to use about a triangle? And let's assume it's a right triangle, I guess. Okay, so yeah, we have to know that it's a right triangle. But how much information, I said that because I heard you. How much information do you need to know about the sides in order to use the Pythagorean theorem?
You need to know 2 of the side lengths.
you need to know two of the side lengths, right? Now when I say side lengths, I mean side, side, side. There are three sides, right? You know, I'm calling the hypotenuse a side. These two we would actually call legs, okay? But they're all three sides. These two are legs, and that's the hypotenuse. But the bottom line is that Colin says we need 2 out of the 3 sides. Then we can find the third side. I want to challenge that right now for a second, though, because what if I knew this? What if I said, here's a right triangle, and I want to find the hypotenuse, and I know that that side is 5. At this point, you'd probably say, well, I can't use Pythagorean theorem. But what if I told you this? Those sides were the same. And you only know one, but technically if you know one and the 2 sides, then you do know what? You do know 2, okay? So, if that was 5, quickly on your paper, go ahead and solve for h again. Should be able to solve for h fairly quickly now that we know what we're doing, as long as Gary's prepared. Yes, I'm going to pick on you all class period. This is it.
I'm telling my parents that you're picking on me.
This is it. Okay, good. When you do get that radical, tell them to call me. Can't fire me because I got tenure. When you get a radical, I want you to make sure you simplify the radical. I see people aren't simplifying it. Okay, simplify that radical. That doesn't mean use your calculator to get an estimate. You could do that, but I want you to simplify it. I see everybody's got square root of 50 and nobody's simplifying it. Come on, you know better than that. It's crap we did in Algebra 1. It's geometry. I'm not even going to do the middle steps. Everybody's got square root of 50. All right? Well, when you simplify that, square root of 50, what? What's simplify to? Anyone? Everybody should be able to know that. Column what?
5 times square root of 2.
5 square root of 2. Okay, good. Now that approximately is 7.07. I don't care about that, okay? What if I said this, though? What if I gave another example, and I said, same thing, isosceles then, right? Should have asked you that question. What kind of a triangle is it if 2 sides are congruent? Isosceles, thank you very much. All right, so what if I said this? What if I said I only know one leg, but I know the other one, obviously, too, is 3? Go ahead and quickly do that one, too. Make sure you simplify. Yeah, I'm liking what I'm seeing here. Square root of 18. Simplifying to, I'm not doing any middle work. Simplifying to what? 3 square root of 2. Does anybody, this is the relationship I want us to focus on right now. Does anybody see any relationship between the side that I gave you and the hypotenuse that you got? Anybody see any relationship there? What kind of relationship are you seeing? Maddie, what kind of relationship are you seeing?
They're both multiplied by square root of 2.
This number here is the side, and then you're multiplying by the square root of 2. That's where I want to kind of focus on today, okay? All right, so today, main things, objectives. Brittany, read the first objective.
State the names of the 2 special right triangles.
Okay, so you notice my topic today was special right triangles. So the first objective is I want you to be able to state the names of the 2 special right triangles. So right there, how many does that tell you we have? How many different kinds of special right triangles do we have? 2. You don't know what the names of them are. We're going to call them Johnny and Brittany. No, we're not. Okay, that is not the official names. But we're going to find out what the names are. Second objective. Read that for me, Gary, if you can't stop eating in class.
Explain how the relationships found in the special right triangles allow us to solve them when we only know one side length.
Okay, so look at this carefully. I want us to be able to explain how the relationships found in the special right triangles allow us to solve them when we only know one side length. Now, that's a little different than the Pythagorean theorem because you told me we needed 2 side lengths. on the special right triangles, we're only going to need one. You already know one of the relationships right here. The side, the hypotenuse with square root of 2. Right. Read the third one there, Maddie.
Solve special right triangles using the relationships discovered.
So we're going to actually, now not only we're going to explain them, but we're going to actually go through the process and solve them. What does it mean? We've been through this several times with different relationships. What does it mean when we say solve a triangle though? It means to find what? Find missing sides and missing angles depending on what we're given, okay, and what we're expected to do. So I want us to be able to use those relationships to solve right triangles. And finally, we're going to do what, Colin?
Appreciate how the relationships in a special right triangle and special right triangles are derived.
And possibly derive them if so interested. So I'm going to derive them for us, but I don't really expect you to be able to do that unless you really want to. So here's our motivating problem. So when could this stuff be useful? Here's my motivating problem. All right, so everybody, let's read this problem. It says Gary is flying a sightseeing airplane at 1,000 feet on which Brittany and John are fighting over a seat. Brittany pushes John out of the plane. It's a sightseeing plane which can't actually go about 1,000 feet. You can go like 500 really. But anyway, Brittany pushes John out of the plane. Maddie is standing on the ground, looking at the airplane at an angle of 60 degrees, when she sees John starting to fall. How far does Maddie have to run in order to catch John so he doesn't hit the ground? Draw a diagram that you think would model that situation. Does everybody understand what's happening? Plane's going up here. Brittany pushes John out. Brittany's not a good person. Brittany pushes John out. Maddie's on the ground, looking up at the plane, 60-degree angle. It is her job to run over and catch poor John. Maybe we should have switched the people. I'm just not sure if Maddie's going to be able to catch John. Do not know.
I can break the fall.
You can? Okay. Here's my poor attempt at
News headlines really
plane. Did you see that? I'm going to talk about that today in history.
What happened?
I can incorporate current events in history class.
The person
Watch
that
how I do it. Oh wait, this
broke
is.
the plane?
Don't they already have? They have wheels, right?
Yeah. But I don't think they're down when they're flying.
On the sightseeing plane, they probably are.
Why?
Well, because they don't go up like a jet.
Yeah.
Usually, they're just small little plane, 2-seater planes or something.
Oh, that's what you're talking about when you say
Sightseeing. Oh my goodness. There's not much to see when you're 30,000 feet up. Okay,
I didn't
we're only
really
1,000
know
feet up
what
here.
you're talking about.
Does it look something like this? Here's poor John. I am not drawing.
have more like
I'm not drawing John out or falling out of the plane. I'm just gonna say this is him. Well, okay, whatever. Let's see. We'll go upside down, right? Help!
He's going head first.
Hey.
You really better catch him.
Wait. Oh no. Okay. So anyway, what do we got here? And Maddie's down here, right?
Where? I just get him on.
And Brittany's up here laughing.
Me.
Ha ha, smiling.
Where's me?
What?
Where am I?
Gary's flying.
Oh, Gary's flying. Sorry, Gary's. Oh my goodness, I can't draw a cockpit.
Your assistant is very.
There you are. There you go. See, there
You
you're
didn't
flying.
draw my steering wheel.
You're hanging on to the propeller. Can I just teach my dad a lesson, please?
My plane was
Anyway.
going the other direction. Doesn't matter.
It should. Oh, sure. It should look something like that, right? Okay. So now, what do we want though here? Let's think about this. This is 1,000, right? And we want that distance right there. Now you might look and say, right triangle, Pythagorean theorem, but what's the problem with being able to find that x? What's the problem with being able to find that x saying, I'm going to use the Pythagorean theorem? You've already said it. What's the problem? What do we need in order to use the Pythagorean theorem? We need two sides. You're not going to find x when you only know this. Now, later on in trig class, when you take trig, or actually later on in this class even, in the year, I'll teach you how to use something called trigonometry to find a missing side when you know another side and an angle, okay, in a right triangle. Okay, but we'll bank that. All right, so, but I'm going to say this. Because the angle is 60, that's one of our special right triangles. Okay? And we're going to be able to find that just by knowing one side. So, hang on to that for a second. Okay, first statement you need in your notes is this. That there are two types of special right triangles that will allow us to find the missing sides based on the relationships among the sides. So I want you to make sure you write that down in your notes. That way, when you're looking at then later on trying to solve problems, you'll be able to have something to fall back on. So we're going to talk about two different types of special right triangles. They'll allow us to find the missing sides. Now, I probably should have put something else up there. It says it allows us to find the missing sides based on the relationships among the sides. I should have probably put that will allow us to find the missing sides when given only one, but it's fine. The statement's still valid. And the first special right triangle is a 45, 45, 90 triangle. Now, in my bell ringer extension, you already figured this out because I'm going to ask this question here. 45, 45, 90. Two angles are the same, right? What do you know if two angles are the same? What do you know about their opposite sides? What are they?
Same.
They're the same as well. Okay? So let's look at this type of a special right triangle. And if it's 45, 45, 90, then what you've said from what we know before is it's an isosceles, or the two sides opposite the 45s are the same. So, in general then, and you know what? You already know the answer. Look back at your bell ringer. If I know a side, then the hypotenuse is just the product of the side and what? Square root of 2. Okay? Now, we did that through a couple examples, but let's just do this. Let's say I only know one side, and it's S. Well, then I automatically know the other side. What is it? S. So I'm doing it in general, so I'm proving, right? This is the hypotenuse. Let's use the Pythagorean theorem to set up the formula, set up the equation. What would it be? Gary, what would it be?
S squared
S squared
plus S squared
S squared.
equals H squared.
Here's the cool thing about this, is if they are the same, S squared and S squared, you know how you guys did 5 squared and 5 squared? And you didn't think about that being 2 5 squares, and 3 squared and 3 squared, it's 2 3 squares. You actually did 9 plus 9, and 25 plus 25 in your bell ringer. But this right here, S squared and S squared, well, I don't have any choice but to say 2S squared. That's algebra. That equals H squared. So to find H, you take the square root of both sides, but what is H then? The square root of 2 times the square root of S squared. Algebra 1, you can pull out a what from that? What can you pull out of that? An S. So an S and the square root of 2. Whatever the side is, right? Multiply by the square root of 2, that's your hypotenuse. All the time. Because all I did was use S and not an actual number. So, all I need to know is one side, and then I can find the hypotenuse. So a couple examples. Let's do an example. So let's say, I can draw this example out. Let's say you have a 45, 45, 90 triangle. And actually, I don't even need to write those down just because you won't always see that those are. You have to decide. And in fact, I'm just going to write 145. Because if one of the angles is 45, what do I know about the other angle? And it has to be 45 because all three angles have to add up to what? 180 degrees. So if I say that side length is 6, what I want you to do is find H. And listen, wait. do not use the Pythagorean theorem. Okay? Don't do what I did here and say 6 and 8. Our goal is to look at the relationships in these special right triangles. Write down what H is, because you know it right away. Look at the right. What did we just discover? So you got to make that connection with what we just discovered. I don't need to go through any formula. Brittany, what's H?
6 root 2.
6, square root of 2. Yeah. Do another one. How about 45? And what if this is 20 on a leg? Then find H. 10 seconds, it's done. 9, 8, set. It should be done now. John, what's H?
20 square root of 2.
20 square root of 2, sure. See how easy that is? Ah, does it get harder? No, it doesn't. Well, maybe, but let's see. This time I'm going to give you the hypotenuse, 5. And I'm going to ask you to find the side. Now, wait. This is 20, that's 20, this is 6, that's 6. Whatever I find for M, that's M, right? That's going to be M as well. So this time, I want us to find M. That's going to be a little more challenging. Go ahead and see what you can do with it. See if we can figure out how to do that.
Brady's got something good going on. Gary's cheating on Tiffany. I'm tired of you dudes.
Tenure, that's all I'm saying. Yeah, you just got to go backwards here, right? I mean, think about what I said. You okay? Did you see something in there?
I was super proud of you guys.
Okay. You see if you were given the side length, the leg, you just multiplied by square root of 2 to get the hypotenuse. If we're given the hypotenuse, well, we're given backwards information, right? Because my relationship is the hypotenuse is the square root of 2 times the leg. So the side, the leg, is the quotient of, right? I don't want to say the division of. You know, it's the quotient of the hypotenuse and square root of 3. So,
3.
oh, square root of 2. Jumping a little ahead of myself to the 30, 60, 90. So M is 5 over the square root of 2. Now, I saw most of you setting up an actual equation. And you were doing this, you were saying, well, because you weren't really confident in your ability to just say, I have to just divide by the square root of 2. You said, well, then I know that 5 is M times the square root of 2, and then you solve for M. But that's what you get, right? Now, we also know from algebra that we don't normally leave square root of 2 in the denominator. We rationalize it, which means you got to get the bottom number, get the denominator a rational number. So what was that I multiplied the fraction by? Does anybody remember? It's not something we do a lot of, but what is that? What do you multiply square root of 2 by to get a rational number, which the easiest number would be 2? Multiplied by what?
7.
It's 7, right? So if I multiply the denominator by it, I got to multiply the numerator by it. So another way to get it is 5 square root of 2 over 2. Okay. Now, typically, if this is a real life problem, like John's falling out of an airplane, and Maddie has to figure out how far she has to go, we're probably going to estimate it anyway, because if Maddie says, well, I gotta go with 5 square root of 2 over 2, she's gonna have to go to the store and buy a calculator first and figure out what that is before she actually knows. All right, so with that in mind then, make sure we have this in our notes so we know how to go back and solve when we're doing our homework tonight. So in a 45, 45, 90 triangle, the hypotenuse is the product of the leg length and square root of 2. Or the leg length is the quotient of the hypotenuse and the square root of 2. So basically what I'm saying there is if you're going one way, which is know the leg, find the hypotenuse, you take the product of the leg and square root of 2. If you know the hypotenuse and you're trying to find the leg length, then you take the quotient of the hypotenuse and square root of 2. How many special right triangles did I say there were? Maddie? 2. Type 1, 45, 45, 90. Second type, 30, 60, 90. 30, 60, 90 triangle. This one's a little more difficult. Okay? Best way to see the relationship, though, is for me to begin with an equilateral triangle, which an equilateral triangle, I'm going to say this, and you're going to tell me why. An equilateral triangle will not have a 90-degree angle, so it won't be a right triangle. Now think about it. Why? An equilateral triangle, all sides equal, will not have a 90-degree angle, because if it's equilateral, what do you know about the angles? They're all what? They're all the same, equal. And 180 divided by 3, each angle is how much? This is all stuff we know from before. Is what? 60. So there is no 90-degree angle. That's why it's a little bit more difficult, because you might say, well, let me go draw a 30, 60, 90 triangle. Well, true, but you then would have to extend it to an equilateral triangle to find the relationship that I'm going to show you. So I'm just going to start with an equilateral triangle. Okay? Now, anybody remember anything about the altitude of an equilateral triangle? Yeah, this has been a few weeks, I know. But when I say altitude, I mean from one of the vertices to an altitude just goes perpendicular, so there's my 90-degree angle, right? Anybody remember anything that the altitude does to the angle that it comes from and the side length? Anybody remember that? Or even what's it look like with my poor drawing? It's not that drawing. What is it, Maddie?
Cuts in half.
Cuts what in half?
The angle and the side.
Yeah, it cuts the angle up here in half and this side in half. Okay? Now, to make sure that so there's, you see my 30, 60, 90 triangle then? 30, 60, 90. Alright? But now I want to be very careful here, because I know it's probably tempting to say this. Well, if the side length is S, then this is half S. Not a bad way of doing it, but I can show you this relationship better, if I call the half of it S instead. Okay? Because if the half of it is S, then the whole thing was what? 2S. Thank you, Gary. You're getting better today. If this is 2S and these two sides are the same as this side over here is what? 2S. I do it that now. Yeah. If I'd have said this whole thing was S and this is half S, well, this is S, and you'd still see the same relationship. But now it might be a little easier to see. Here's the short side. We know from before, short side off the smallest angle. This is the short side. That's the hypotenuse. What's the relationship between the short side and the hypotenuse? It's right there in front of you. What's the relationship between the short side and the hypotenuse? If the short side is S, the hypotenuse is 2S. Give me in words what you can say about the relationship between the short side and the hypotenuse. The hypotenuse is what? The short side? Double. It's double the short side. So the only thing that's left is for me to find that. So part of my statement, I'll organize it for you in a second for your notes, but part of my statement is going to be, in a 30, 60, 90 triangle, the hypotenuse is 2 times the short side. Let's figure out this long side then. And we got an idea of how I can figure out the long side? S, L, 2S. I mean, what relationship do I use? What relationship gives me the relationship between the three sides of a right triangle? Well, what? Pythagorean theorem. Side length, hypotenuse length. So, and again, I'm not expecting you to do this. I'm expecting you to follow me and understand where this came from. And if you want to be able to derive it, that's fine. But check it out. I would say s squared plus l squared equals 2s. That's my hypotenuse squared. Let's see if there's a relationship going on here. S squared plus L squared equals 2S squared. You gotta be careful squaring that. What is 2S squared? 4S squared. If I take S squared over to the other side, right, subtract S squared, L squared equals 3S squared, which tells me L is the square root of 3S squared. And L is, what can I pull out of that? Just like I did with the 45, 45, 90, what can I pull out? S square root of 3. Tell me in words then. Tell me in words. I'll tell you the first words. The hypotenuse is twice the length of the short side. You tell me what's the relationship between the short side and the long side then, based on that relationship. Think about it and share with your partner. See if you can get a good phrase. Say it in words, okay? Colin, what do you got? What's your group saying? What's the relationship between the short side and the long side?
It's the short side. I mean, the long side is the product of the short side. And
yeah. See what this and the square root of 3. See what this says? It says the long side is the product of short side and the square root of 3. All right. So we need that statement in our notes before we do a couple examples. This is going to help you out at home. We got a couple examples of this right here, and then we got to get back to our motivating problem because John's still faulting.
Oh, we never solved that.
So in a 30, 60, 90 triangle, the hypotenuse is twice the length of the shorter side, and the longer side is the product of the short side and square root of 3. And then, just so you know, if you're given the short side, that's a good relationship. But if you're not given the short side, if you're given the length of the longer side of the hypotenuse, you just use the same relationships. Pretending to write notes. So when your mom called me up and said, "Why can't he do his homework?" I said, "Because he didn't write notes down." All right, so you can look at this example here. You look at this example here. We have a 30, 60, 90 triangle. I don't have the 30, but it has the 60, but you know it's a 30. I've given you, now you tell me, is this the short side? Is 10 the short side or the long side of the hypotenuse? Which one is it? Short side. Everybody find N and P. I don't mean find N and go P. I mean find N and P. You're going to have to wait because this is important. Class time is sacred to me. I love people pay. So it looks like N is what, Gary? 20. Because N is twice the shorter side. It's the hypotenuse. So it is 20. P is what, Brittany? It's the short side, the product of the short side and the square root of 3. So there's nothing else to simplify there. Okay? How about this one? Do one hard one here. How about, there's my 30 up here. This time I'm going to give you, which side did I give you? That's not a 5, it's an S. What side did I give you? Did I give you the long side or the short side? I gave you the long side. Find X and S.
So you're saying that the short side is half of the long side. Read your statement. If I had given you the hypotenuse, then you would take that.
I actually said find X and S for a reason instead of find S and X, because I'm not convinced that you could find directly the length of X knowing the long side. You got to go through the short side. Everything works off of the short side. Nothing in my statement says any kind of relationship between the hypotenuse and the long side. Not that there is one, or not that there isn't one, there just isn't an easy one. You see what I'm saying? But I asked it that way, so you'd have to try to, I think you have to get S first. Because, remember, John made this mistake here. He said that S is half of that. Common mistake though, John, common mistake. It's hypotenuse, or it's the short side that's half of the hypotenuse. And I'm not giving either one of those. So, to find X, I don't know that I can find X directly. Other than to say, you understand, here's your relationship, right? Your relationship is that from the long side to the hypotenuse is half of the long side and square root of 3, right? So it's the product of the long side, the hypotenuse is the product of the long side, 1/2, and the square root of 3, or square root of 3 over 2. You could say it that way. But that's odd when it's much easier to think of the square root of 3. So I'd probably say find S first, because S, if this is square root of 3 times that, then to get to this, I do the opposite, which is what? Divide 7 square root of 3, or in the interest of time, 7 square root of 3 over 3. I think you should be able to know that from Algebra 1. And then X is what relationship with that? Twice it, right? Twice it. So 7 square root of 3 over 3 times 2 equals 14 square root of 3 over 3. All right, so John's been following for a while. Go back to the side, or go back to wherever you drew it. And over here on the side of the paper, piece of cake. All we need is our calculator. Because John's falling 1,000 feet. How far has Maddie got to go to catch him? It's a 30, 60, 90. What's the relationship? We just did it here for this last example. What's the relationship between 1,000 and the X? What would I have to do to find X? What do I do to my 1,000 to find X? Anybody? Divided by the square root of 3. So it's 1,000 divided by the square root of 3. Now, because this is a real life problem, I'm not going to worry about that rationalizing stuff. John's already got it punched in his calculator. How about, because he's a little worried if Maddie can make it or not. Notice he's the one that grabbed his calculator first. What is that approximately, John?
577.
577.4 feet?
Dang.
Now, totally another question to figure out whether Maddie has time to run 577.
So how many miles do I have to run?
Well, let's see. If a mile is 5,280 feet, right? So about 5,000, that's about 500, say. So we're just estimating, right? So about 1/10 of a mile, right? About 1/10 of a mile.
Not bad.
See how I use my estimation skills? So about 1/10 of a mile. So you're running from here to Ulmer. Okay? Now, the question is though, does she have time? Because John's falling quickly. Okay.
Even use her mile.
Yeah, how fast is your mile? And you're pulling a cart now. I don't know. Anyway, all right, in closing, how many special right triangles are there? And what are they? How many special right triangles are there? And what are they? Feel free to look in your notes, but how many are there, Colin?
2.
There are 2 of them. Name me one of them, John.
45, 45.
Yes, and name me the other one, Brittany.
30, 60, 90.
30, 60, 90. Excellent, excellent. How many side lengths do we need to know in order to solve a special right triangle? How many side lengths do we need to know in order to solve a special right triangle? Maddie?
1.
Just 1. Unlike, that's why it's different than the Pythagorean theorem, right? Because Pythagorean theorem you need 2. Now, of course, sometimes if you know one in special right, you know another. It's isosceles, it's 45, 45. In a 45, 45, 90 triangle, what's the relationship between the hypotenuse and the legs? What was that relationship? You got a statement in your notes. You don't have to memorize it. What is the relationship between the hypotenuse and the legs? What is it, Gary?
It's the product of the leg and the square root.
Okay, hypotenuse is the product of the legs and the square root of 2 product of one of the legs, not of the legs like you multiply together. In a 30, 60, 90 triangle, what's the relationship between the hypotenuse and the shortest side? In a 30, 60, 90, what's the relationship between the hypotenuse and the shortest side? Again, you got a statement in there in your notes to look at. What is that relationship? Colin, what's that relationship? What's the relationship between the hypotenuse and the shortest side?
Shortest side is the product of 2 times the shortest side.
But the hypotenuse.
Yeah.
The hypotenuse is the product of 2 times the shortest side, right? You said the shortest side twice in there. And then I'll say this later on in the course, we only have 2 right now, but technically, when it comes to trigonometry, every right triangle is special, okay? It's just that we don't know it off the top of our heads. We need some tables or our calculator. So in trigonometry or later on in this course, I'll help you find the missing side when you only know one side in any triangle. But technically, you need a side and the angle. Okay. All right, last problem is to go out the door on is, and I'm just in the interest of time, I'm not going to do it. I have a last problem for you, which is just 30, 60, 90, and to find it. So, okay. So, talk to me about, and that's about the same time, about 35 minutes that Colin took there. So, what differences, if any, do you think were in the way I structured that lesson than how Colin did his? But it had the same information. I hope you understand it had the exact same information. So as far as either structure goes, or, which obviously is part of organization, or how I actually carried out the plan and wanted to make sure students knew how to do things in the end. How did it differ? Try to ignore personality differences, okay? I'm much more comfortable, than Colin, so ignore that part of it. That certainly has something to do with how well students learn and that, but I don't want to compare that part of the lesson. I just want to compare structure and how it was implemented or what I expected out of students. How is that different? How is it different? Colin starts out, obviously he saw both, or he was part of both.
You showed the relationship between a 45, 45, 90 just on that triangle, and then you showed us the relationships 30, 60, 90 separately. You didn't bring them both in at the same time.
Okay, so I tried to make sure when I was doing it, and I have to do this consciously, and I posted my notes too to today's time. in live text. But I have to consciously do this too, because I want to stand up there and derive everything and do problems and all that, right? When I start writing too much down that I feel like I'm going to say, I have to make sure I say, I got to stop here and give my students something to do. So yes, while you probably looked and said, I have to teach 30, 60, 90, and 45, 45, 90 triangles, I'm going to get all the information and then provide them with examples. Unless all of the information can be done in about 10 minutes, less than 10 minutes, don't do that, okay? Chunk it. Break it apart somehow into, okay, let me do a little bit, give them something to do. So I feel like I was constantly doing something. Bell ringer, you did something. I said a few things, and then you did something in the sense of reading the objectives. Even though, yes, I was expanding on, but I didn't read the objectives. You did something there. I gave a motivating problem. You drew it out. We talked about it a little bit. I gave the notes. I derived the 45, 45, 90, but then immediately had them do examples. Then we went to the 30, 60, 90, derived that, immediately gave them examples. Okay. So yeah, a little bit more of that. What else? What else? Matt.
You did more of like asking us to find things. Like Colin just said, this is the relationship.
Okay.
You kind of made us find it ourselves.
Which doesn't necessarily have anything to do with personality. You might think it does. Well, he can draw things out better, whatever. But it has more to do probably with fear of what students are going to be able are going to say too. Okay, and with that comes knowledge about the curriculum and knowledge about the mathematics that you're teaching, because you want to ask your students so they can make some connections, right? I mean, the fear, especially for new teachers, and it's a fear for me whenever I'm teaching something new, is just to get it all out in the open, and I want to say everything the way I want to say it, and I don't want anybody interrupting me. But asking questions and having them do some stuff, the fear is, what if you do something wrong? Okay, but I have to. That's the difference between teaching and explaining. You know, is there part of teaching that is explaining? Yes, but you're teaching. The focus is on the students, and so I need to have them, do things, whether it be responding to questions and oh my goodness, I'm not sure what they're going to say, or doing problems and oh my goodness, I don't know what they're going to do. But stopping myself from doing too much is key. What else? What are some other aspects? Where did I put my motivating problem? At the beginning. Did we solve it though? There. No. It was just show them where the usefulness is, right? I mean, I know it's not a very useful. It's a contrived problem, right? So we can start with a motivating problem, even if we can't solve it. Solve it at the end. Solve it at the end. But you remember that problem. So that's one of the things, okay? What else? Did I cue note-taking? And I made you write notes, right? I knew exactly what I wanted for you to have in your notes, right? Now, maybe Gary said something about, well, is it okay if I give some of the note packets and that? It's fine. If you want to do that. I mean, I like if I'm teaching multiple sections of something, like it's okay if I'm writing on the board if I'm only teaching one section, except that does take time for me to write on the board. But the fear in having things on PowerPoint or on a slide somehow presented is that I'll go too fast, and I will give them the time to write down the notes. I think I gave you enough time. I mean, somewhere I know still doing a little bit, so there is some virtue in note packets. But I will say this, that having my statements on the board or on a slide like that is still going to take you less time to write it in your notes than it would me writing it on the board and you writing it in your notes, okay? Because if it's already written up there, then I can make sure you're writing in your notes, and I can walk around because I don't have to write it on the board. If I write it on the board, while I'm writing on the board, you might be jerking around, And then after I get done writing it, now I have to stop and make sure everybody writes it, on the board. Because some people won't, depending on how I stand in front of the board, some people won't write while I'm writing. They'll, wait till I'm done writing. So it can take double the amount of time. But again, the point there is, everything I thought was really, really important. Not all my questions. There's a lot. You can look through my notes. There's lots of questions in here that I have written down. But I didn't put them on the slides. It was the important things, the statements, things they need for their notes, the definitions, whatever it is. Those things are. And I didn't tell you to write down the objectives. I don't care if you write down the objectives or not. But the statements and what those are, those were there on the board for you right now. Anything else? What else? I mean, I did pretty much everything that Colin did, right? Derived the stuff, did the examples. But important things written down, the closing questions. I have them written down because I want my students to, and we're seeing here in our learning theories, I want my students to hear them, and I also want them to see them. Not because Gary's a visual learner and he has to see the stuff, but Brittany's an auditory learner, she's okay with just hearing. Not because of that, but because we all learn things by seeing and hearing. Okay? Whatever it is psychologists tell us we catch 10% of what we hear. And if we hear and see it, we catch like 25%. If we hear, see, and do it, then we catch like 50%. If we hear, see, do, and teach it, that's why you think your teachers know things so well. But they don't know because they've taught it. If I hear, see, and teach it, I remember like 80% of what I did. That's crazy.
You forgot touch.
And touch it? Well, I guess you can touch that. I don't know, other things, anything else that you notice? Speak now, verbal, please. But I think the organization, try to get out of the mode of I'm going to tell my students everything and then have them do things. That's good that you're having them do things, but we have to have them, it has to be chunked. And I think we can do a little bit better job of that. Okay, let's go with our learning theories. I want to keep discussing learning theories and finish that today. And get you ready to finish your next project. So Gary, you're going next Tuesday.
Yeah.
Your teach. So the
Now-
pressure's on for the next 3, right?
Yeah. But I didn't figure out exactly how I want to do it, but if I do want to decide to do a PowerPoint,
Yes.
should I just email it to you?
You can, or you can just email it to yourself and just log in.
I'm
Your email.
fine.
You can just grab your email. Yeah. Yeah, I mean, certainly you can email it to me too, but. Yeah, I mean, I always think, especially now with so much putting things on a learning management system like Schoology people use, like a D2L and Live Text. It's all some learning management system where electronic documents can be uploaded. I don't. Is it good that students write things in their notes? Yes, it is good. Note taking, yes. But if we post our electronic resources, like I would just post that right there to Schoology or whatever I'm using. I have it posted to Live Text. So as you're studying tonight at home and doing the homework problems, wait, what did he say? Well, I can't read my notes, or all I have are examples in my book. This is like the worst thing I think that ends up happening is I go home and all I have written in my notebook are examples. Think about what that is telling your students. That's telling them that you have to memorize everything that I did and all the statements that I made. And it's just math class. But it's math class and English class and literature class and world history class and all those other classes too that they're doing for. So we've got to give them better notes of some sort. Cue the note taking. They can pull it up electronically if they want and say, oh, there are the notes there. I got to train them to it, because when they come home or when they come to school tomorrow and say, well, I didn't know how to do these. Well, but the notes are there. There are statements, and I like the statement thing, because statement is something particular that you need to do or remember or use or something like that. So I like those. I like the statements. Sometimes they're definitions, right? I usually distinguish in my notes between definitions, statements, and then problems, and probably some other things too. But those are the three like main things. Certainly, if I'm teaching geometry, I change my statements to I add in there theorems, things like that, because this is an actual theorem that I'm using. Okay, so thinking about ways to view learning, the first way to view learning, and really I think it's a way to look at your kids, is through the lens of multiple intelligences. And what was that, on page 10 or something?
Yeah.
And I just think that looking at that, understand what multiple intelligences is. It's opposed to the one IQ. Like we have an IQ, which is kind of falling out of favor anyway, but we still give IQ tests, and your IQ is 127, your IQ is 98, your IQ is 140, whatever it is. And that is supposed to be a general intelligence quotient. Well, if you think about those things are, those, if you ever looked at those tests and that, they certainly aren't very interpersonal and intrapersonal and musical intelligence and kind of kinesthetic intelligence. So the viewpoint here is not looking at somebody's IQ and saying you're smart or not smart. It's looking and saying, what intelligences do you have? Because even though, yes, there's certainly an argument that would say, okay, well, you're a really good basketball player, you're a really good football player. Do you realize that 1/10% are going to make it to the NFL, NBA, whatever, and be able to make a living out of basketball? Well, I don't know if that's entirely true. It's entirely true from a professional sports position, but people make livings out of coaching youth, right? Coaching YMCA, that's what you do. People make livings out of, I wasn't a great athlete, but I liked the sport, I knew the sport, so I become an analyst, right? I become a communications person, and then maybe a reporter, something like that. But it doesn't have, so we kind of knock those kinds of intelligences sometimes because they're not mathematical and things like that. So look, just looking at your students through the eyes of saying, hey, you have this linguistic intelligence, even though it's a math class, and that's okay. You have this musical intelligence, logical, mathematical, obviously. You have this bodily kinesthetic intelligence, intrapersonal intelligence, interpersonal. Can somebody make a good living out of being a person who is very extroverted and gets people motivated to do things? Well, sure, the world needs community organizers, right? We need those kinds of people. Does the community organizer have to take trigonometry? Probably not. Now, do they need to know basic math skills? Yes. But until we find a way to teach, well, I think there are ways, but until we accept the ways to teach algebra in a way that is for everyone, instead of only abstract to look at the keystone type of problems on exams and solve equations, then we're probably in a losing battle to say those people there aren't going to succeed in life if they don't take trig and calculus and do well in algebra and stuff. And we've said before, testing, formal schooling, primarily lie in the linguistic and logical mathematical intelligences. I mean, y'all have friends who are just not good in math, right? really good at doing something. I hope. You just hang around math people who got issues. You try not to be too hard. We're learning. We're talking about helping all of our students learn here. You can't. Yes, you should push your students in math, but you should also understand that you're going to succeed at doing something, and don't make them feel like they're not going to succeed in life because they can't do math. We want to encourage them to say, find your niche, but also do well in math, or do as well as you can, in math. So. Another way to view individual learning is through learning styles or learning personalities. So the first one, the first learning style here, and again, this goes to just learning everything I can about my students. Have you heard about like the Myers-Briggs personality test? Maybe you haven't. Usually you talk about those someplace in psychology class. Myers-Briggs type, it's most popular in education circles, as I try to understand the kids in my classroom, because me being a very extroverted person has to understand how I get my energy and how I view the world, but the introvert in my class isn't going to always respond to that, and so I have to be aware of that, whereas the other extrovert I may clash a little bit with, but I can probably relate better to them. So when you study these, and in the past I've taken some time to, actually everybody takes a test to learn what their style is. You can probably pretty much guess which one yours is, and math people tend to have similar similar personalities, but certainly you can Google Myers-Briggs and take a test and see what it is. But what the Myers-Briggs basically does is it determines your preference for learning, or I don't know if it's preference for learning as much as it is a preference for viewing the world in 4 different capacities, and they're dichotomy, so it's one versus another one. So extroversion versus introversion. This describes where people get their focus, or want to focus their attention and get their energy from. So do you get it from the outer world of people, that would be the extrovert, or the inner world of your own mind and experiences? So for instance, for me, people motivate me. So I could be in a really bad mood and just not happy with something on my life, but when I come in here to a classroom, I'm going to be probably excited. Some people might look and say, well, Steve's always happy, he always has a bad day, or he always has a good day. No, that's not true. Sometimes, I'm out running or driving my car and I'm pissed off at the world, okay, or my wife, or kids, or you. No, but yet when I come in and teach, everything is better because that's where I get my energy. Yeah.
Do you think most teachers have to do that?
Well, I don't think that's a good question. I don't think that they have to be like that. I think many are. And then I think because of the troubles because this is easy to do, because of the troubles and difficulties in education and with dealing with other people's students, or sometimes your own, that would piss me off. Sometimes you can let that get to you, and you can become introverted even though you're an extrovert in front of the students, because things are always gnawing at me. It's easy to do. But that doesn't mean, while I would probably say most teachers are some sort of extrovert, it doesn't mean that an introvert can't be a good teacher. That's what it also doesn't mean that. But it does mean, it may mean that an introvert needs to act more, pretend more. Like, it's easy for me to come in and act and pretend like I'm in a good mood just because I'm an extrovert. But if I'm an introvert, it may take a little bit more energy to act. The other one is sensing and intuition. That describes how people prefer to take in information, because we're going to provide information. So think about it from the other perspective. They're going to take in the information I provide them. Now, I don't want to provide information only the way that I take in information, because I've got to reach everybody. So How do people take in information? Is it focused on what's real and actual? So that's the sensing part. Or is it on patterns and meanings in data? So is it more like intuitively? It's my intuition that this is happening. Whereas the sensing feeling, what's real and actual? I gotta touch something. And this is, when I touch it, I take it in. Or patterns and meanings in data, can I just see stuff, hear stuff, and take it in because I have good intuition? So that's that's the second type of how people take in information. Thinking and feeling describes how people prefer to make decisions. Now I'm going to make a decision. So, am I going to do it based on logical analysis, which is the thinking, which is probably most math people. We try to be logical about things, and if it doesn't follow my MATH200 rules, right, my logical rules, then it's not true, okay? Or I'm not going to make a decision like that. So, when my wife and I talk about what a decision we're going to make, I'm very much thinking, and she thinks too, but she feels more than I do. And except when she punches me, then I feel more than she does, which is quite often. So the thinking part, though, when she can sometimes get upset with me because when we're trying to make a decision, I'll say, okay, now wait, let's think about this. If you follow that to its logical conclusion, this is going to happen. And some of you are like that with your friend, and then that's when you get hit, right? And she's like, well, I don't care about that. I just want to do it. That's the person who's feeling more than thinking, right? And you know what I mean there. Okay? But your students are going to be in that realm too. So just because you're logical and this is how you make decisions, don't sit there and say to your students, how can this manifest itself in the classroom? Don't sit there and say to your students that you got to think about where that is going to take you. If you try there, like I want to just try this method here, and I'm sitting there, but I'm also saying because I know what's going to happen, right? Well, if you think about what you're doing, it's going to do this and then this and then this. But I just want to try it anyway. No, don't try it. I'm telling you, it's going to fail. Try it. And we should, because of those people in our classrooms, I should also have that mentality in my class that says, I don't know what's going to happen. Right? What do we learn in history and math? Nevertheless, I will operate. Remember that story? It's like, I don't know what's going to happen here. I'm just going to do it. I'm not going to think about it anymore. I'm just going to do it and see what happens. And the last one is the judging or perceiving, which describes how people prefer to deal with the outer world. Do we do it in a planned, orderly way? You did this, you did it, these are the consequences. I'm very judgmental, right? Or do I some flexible, spontaneous way? Okay, so talking with some colleagues this morning just about our professor. Okay, and these personality traits of yours change over the years. I think, especially as teachers, as you deal with more people. Okay, because I've always been very judging, in an orderly way, in black and white. Black and white. Talking to our secretary, and she was like, well, I see things as black and white, and I used to see things more as black and white, but because I see difficulties that people have run into because things are black and white, I try to be much more perceptive and deal with things in a flexible way. People are saying this person should not have a job, and then but then I look at it and I'm like, okay, and I realize that there's a victim out there. Okay, somewhere there's a victim out there, and we don't know the circumstances. Okay, but somewhere there's a victim out there. I don't know how bad it is, or what. But part of me says, okay, 30 years ago, right? And let's say you've been a model. I'm not saying you have, but let's say you've been a model citizen after you did your time. I realize that there's a public perception, but our law says you do this time. You went through rehabilitation. Now the question for me next is, do we now tell that person you can never work anywhere? Then stay in jail. Then give them the death penalty for everything, right? If you're never going to let anybody who comes out of jail get a job. Or is it, well, you can't have a job in the public sector, taxpayers paying it, working with potential, people underage. Okay, well, private industry can hire you. That's fine too. But so I try to be a little bit more flexible like that. So just realizing that people act differently and you act differently, knowing your personality and knowing that other people are going to act differently is just a good thing. So, let's see. Oh, there's something else. Really thought I'd get this here because I need to get you on your.
You don't need to.
Well, I need to get you on your small projects too, but I need more than 5 minutes. So I'm going to continue with this and then small projects. I mean, two weeks, technically 3 weeks. We'll look at. You can read it next Tuesday, but your small projects, just having 2 weeks to do it is plenty of time. So keep going here though. Another style is what's called the Gregoric learning and teaching styles. If you've heard of people like they're concrete thinkers versus abstract thinkers, sequential thinkers versus random thinkers, that's where this comes in at. So what the first part of this is, how do we understand how we understand our world, called perception. Like, what's your perception of the world? 2 ways, and these are just different styles, or just different scales, I guess, of thinking about people. And I just think that you are going to be in a social science, so you are dealing with people. It's not a natural science. It's not a hard science where you're dealing with chemicals in a laboratory. You're dealing with people, and so understanding people is essential for teachers. Now, having kids helps you understand people, but most of us don't have kids until later on in their teaching career. So I think as a young teacher, you can be a better teacher if you understand kids earlier than when you have kids. So anyway, the first one is, how do you take in or perceive information? Do I do it very concretely? So if you perceive information this way, you see things directly through the 5 senses: sight, smell, touch, taste, hearing. Okay? It's here and now. This is it. You don't look for hidden meanings. You don't try to form relationships between ideas and concepts. It is what it is. There it is. That's what it is. Very concrete. Perceiving information, as opposed to abstractly. A person who thinks this way depends on more visualization or conceiving ideas that can't be seen or touched. So kind of live in the recesses of your mind, very abstractly. So heavily on intuition and imagination, like what could be? What could be? So from a teacher's perspective, allowing myself to be a little bit more abstract in like, well, I don't really know what's going to happen, and I want to figure out what's going to happen first and be very concrete. Let's just go with it and see what it is. I'm thinking that it might be like this, so let's abstractly think about it. How do we organize information? That's the other part. Do we organize it very sequentially or abstractly? Most math people organize things very sequentially, right? Very linear. But not everybody's going to do that. A lot of people, step-by-step manner. That's what we like. Do this, do that, do that. But then think about it, when you get a problem out there, not an exercise, a problem. Exercises, we memorize how to do the steps. Problems, they're just random problems, and we have to sometimes think randomly about it. So if you're sequential, you're thinking about things in a step-by-step manner, very comfortable with a plan, right? The plan is the plan, and that's the plan. And when I go out and a couple weeks, I think I'm going to be running a 10-mile race, right? And I know exactly what I want to do. And when I'm done, probably 98% of the time, I will look back and I'll say, the plan was the plan, and I followed the plan. Okay? And nobody gets in my way. Because when the 13-year-old kid's in front of me, I usually push him out of the way. Or if John's on the plane with me and he's in my way, sorry, John. But follow the steps. I like that. Randomly, though, the person who orders information in a random way, use chunks of information, no particular sequence. You can skip steps. I'm doing this part over here, and then I'll do this part, and then I'll just put them all together. This is why it's frustrating for me to work with my father-in-law when he's building something, because I am a step-by-step. I can follow directions, okay, and I can do this, and then this, and then this, and then this. And my wife's the same way. So if we're putting something together, we usually fight because I read the directions. She grew up with a dad who never read any directions, but he's built many houses, and he has this barn house. So he goes into this big, huge barn, and he built a house inside the barn. Okay? And I'm like, I can't even fathom that. Now I go in, I'm like, this is awesome.
where are the steps? I don't know the steps go up, but, to build it. And he just visualizes things and like, so I can't work with him, in that capacity. People like that are in, you can do that and then put things together and it works. If I was building something here, something there, something there, I guarantee it doesn't fit together anywhere. Unless the leg, right? It's you watch the Lego movie? It's an awesome movie, right? I'm not a master builder, but I can build me some Legos, give me the steps, right? Find the pieces, put them together. But, if my one son, he just starts building crap. And that's awesome. Well, let's see. And then different people who are different things. We'll look at those. We'll keep looking at those. There's no possible way I'm extending.
Please.
It's next Thursday. I even say in here, when am I gonna get this done though? We gotta have teaching. We gotta have teaching. 426. Look, it even says no later.
You said Tuesday.
Nope, she said next.
I know, but then I extended to Thursday.
Good. Okay. That's
Wait,
good.
hold on a second though. Hold on. We're gonna have to do this. This is the only way to do
Can
this.
we do something else?
There's no teaching on Tuesday. Sorry. We're gonna the last 3 days. Thursday, Tuesday, Thursday. Okay. What you just want to get it over with, don't you?
So is that
I don't
a
care.
project
Whatever.
or final?
What's that?
You said we had a little project.
Yeah. So I need to get over stuff on Thursday or on Tuesday with respect to finishing this. We're almost done here, but then to know what your final projects are. And I know it's going to happen if we have a lesson. I'm going to end up in the middle of something. So are you mad at me if I say that?
No.
You sure? Okay. So yeah. So that's fine because that'll give us the last 3 days to do 3 people. And then,
That's the last 3 days.
okay.
So
Yeah,
on paper-
because after next Tuesday, then it's Thursday, Tuesday, Thursday. And we have our final. We'll meet during our final for some other things, but
What is this project?
Our papers due Thursday.
your paper, no, it's not going to be Thursday. It's going to have to be the following Tuesday.
Huh?
This
So
paper,
like when I teach. That'll be
yes,
when I teach.
this
So like
paper,
May 2nd.
yes, but you should be starting.
Oh, are you gonna go Tuesday?
Wait,
what
May
page?
1st.
What page?
May 1st.
Here's your homework.
That's 3-4 page reflection.
Your next, yeah. So
Yeah,
on
May
why are you
1st.
done with it?
I thought it was supposed to be Tuesday.
No.
It was, but we're not done talking about the learning theories. So I can't have it due yet.
Wow.
Okay?
May
I keep postponing. But listen, here is your homework. Here's your homework. You need to read page 115, which is your final projects. I want you to be familiar with those. 115 to 117 describes your final projects you're going to do. This meeting for an hour and 15 minutes is still.
So what you're saying, when you say final
115,
project, it's that page.
115.
No, the paper is not. When you read page 115 and 116, you will see that there are a few final little projects.
Called like evaluating
We're making a
ourselves.
video.
Yes, that involves doing your peer teaching evaluation. There's a little Excel spreadsheet that I have you do. There's a podcast I have you do. You have to write your philosophy of education and a narrated PowerPoint. So we'll talk about those on Tuesday, but read them over. Read them over right now. Or not right now.
Oh yeah.
I'm gonna die before the semester starts.
No, you won't. You don't possibly.
Everything's getting pushed back, so I'm like,
Yes, I know.
Yeah, but we should be doing.
I know. This is killing us step by step. But listen, the only thing you have to do is read those final projects for Tuesday.
what was it,
Okay,
115?
page 115 in your course book.
And these are all due during finals.
And those are due during finals week, yes.
But they're all.
That's your final project.
During the week or during the day we come in?
Well, the day you come in.
Are we gonna work on that?
Now,
Yeah, I even,
You have work days.
with the 3 people, well, I know, but we're not